So event data is everywhere. It's in our bots, it's in our web applications, it's in our cars now, it's in our Fitbits. And we're in this place where we can finally start collecting all this data, and storage is cheap enough that we can be collecting millions of events each day. So first, I want to introduce myself. I'm a community engineer at a data analytics API company called Keen.io. And I work on all things from documentation to helping support our developers, to special side projects, just all over the board. If it's developer facing, I probably have touched it in some way. So first, I want to start off with a definition. Analytics is the discovery and communication of meaningful patterns in data. So with this in mind, I have a few data stories. A little bit of a lag. So there once was an astronomer named Tycho Brahe. He was a 16th century Danish astronomer who created his own observatory, created his own instrumentation, and he even created his own paper mill so he could have data storage systems. And every night, he would go out to his observatory and record all the locations of all the stars and the planets. And he did this until one day he died. But luckily, that's not the end of the story. He had an assistant named Johannes Kepler. Probably the more familiar name out of this story. Johannes Kepler, for 2 decades, then took all of Brahe's data, ran calculations over it, and single-handedly discovered with his data the planetary laws of motion, which then Newton and Einstein used, and NASA calls it the launch of the scientific revolution. Because of Brahe's data collection, we were able to get here. So this is a story about data collection. The next story is about data analysis. So what can we learn from the data? There was once a scientist at LinkedIn, or in the early days, who was testing different theories around who was in different people's networks. So this was before the people you may know was there, and there was only uploading your address book to find your network. And he had this idea that you could potentially introduce people based on where they worked and where they went to school. And the problem was the engineering team at the time was pretty openly dismissive of this idea. They had scaling problems. They didn't understand why you would need to do this when you had an address book. And so they just kind of pushed them aside. But luckily, LinkedIn's one of the co-founders and CEO at the time believed in the power of analytics from his time at PayPal. And so he gave the scientist a little module that was actually ad space to kind of circumvent the traditional product release process and put whatever he wanted there. And so we started out with people's where they went to school, where they worked. And then later, he was starting to get like extremely high click rates compared to the rest of the site. And so we started using networking ideas like triangular closing, thinking like, so say I know Larry and Sue, there's a good chance that Larry and Sue know each other. And introducing that as possible connections. Other managers at the time started realizing like how successful this was being. They were getting 30% higher click rates than other pages, and it soon became a fixture on the LinkedIn homepage, which still is today. And this was all possible because they believed in the power of analytics, and not only to get value out of analytics, but also prove value. The last story is about data visualization and communication. So what can we learn? How do we show to others what we've learned? And cholera hit London in 1854. In one street, within just a few days, over 127 Londoners died. But there was this man named John Snow who figured out that cholera was being spread through water, but no one believed him. So he went on a data collection mission, and he created this map. Per the map, he marked deaths by little black bars, and he looked at places like the brewery, which actually had no deaths, and the workhouse, which had very few in contrast to how many people that were actually there. And then there were the concentration of all the dust around the water pump. And part of this that he figured out was the brewers were drinking beer and the workhouse had their own pump. And so as soon as he showed this to some people in the city, they turned off the water pump and the death stopped. So this is showing an example of bringing together collection, analysis, visualization, and finding ways to communicate the data to help save lives. So you may have heard every software company, every company is becoming a software company. Well, I want to add one to that. Every software company is becoming a data company because of all this data that's going on within our applications, our bots, that we're really just sitting on top of massive amounts of data. So what exactly is when I say event data? Event data has an action, so the thing that the actual person or user is doing. There's a state, so all the relevant information around that. And then there's time, the exact timestamp. Now, this isn't necessarily in strong contrast to your traditional like entity data, which is more what you see a lot of state data. And it's a complementary thing. So to compare it though, we're gonna look at some entity data. So you have different Twitter accounts with their UID, their Twitter handle, their age, and their account ID. If someone changes age, that disappears. I mean, you may have backups, but that is then replaced. They may change their handle, again, replaced. With this type of data, you're typically seeing it in your relational databases, and that's what we're typically used to. But I want to contrast that to event data, which is a little bit more flexible. I'm showing this in JSON because to show some of this flexibility, but this is a death event in Minecraft. What is the event? A death. And then you have all the state information. What was the cause? A creeper explosion. And then like the enemy and player information and the timestamp. But the thing is, like a death event could also be caused by something else. So maybe there isn't an enemy, but we still want to be able to compare those two types of data together. And it's easy because it's your event databases are a little bit different than your typical schema databases. And so we can easily change and manipulate things, and we're not having to join all these tables together of different types of entities. Here's another example from a bot that is a message received from a made-up bot that I sometimes run for examples called CorgiBot. I'm also combining other sources of data in this bot. So I'm doing some conditionals around what the actual messages is, which script it might be triggering. So it's a greeting because they said hello to it. Also more team information and just data from other sources. So a little bit more of the comparison between entity and event data. So first, strict schema versus flexible schema. So let me make sure I'm right. Event data has to be flexible because events might have different properties in them, like we talked about before. So they can easily change, or maybe you want to add new data sources, but still be able to do analysis on the same events. Also, so an example of that, besides the Minecraft event, would be like page views. You might have a user or you might not have a user, but you still want to be able to do analysis on all those page views together. Another one is normalize versus denormalize. So just in case you don't know, database normalization is when you're trying to reduce the data redundancy. It's really hard to maintain objects in a lot of different places with the same information. Think of that as the number, if you repeat a fact, the more times you repeat it, the harder it is to determine validity. And so in event data, because you are collecting the state info every time, it's more denormalized style of data, which for some people might be slightly unnerving if you're typical like SQL veteran. But in order to capture the state at the time of the event, you have to. Otherwise, that information will just be missing. And then, as we kind of touched on, describing nouns versus describing verbs. So think of that, entities versus actions by entities. So nouns being a user, a team, a company, versus verbs being a message, a button click, different things like that. And then you have updates versus appends. That's something that I've noticed a lot of users struggle with event data, is they want to update events. But a lot of it is, if we update the event, then we lose the previous state. And we lose the historical real-time events. And so if a new event happens, we just add a new one. And so then we're appending that data. This also causes the data to grow in size, which is kind of why it's harder to put it in your traditional schema database. Another thing on that example of that thinking is like tracking the number of messages and just like keeping an updated count versus tracking each message and then doing a count of those messages. The last one is describing now versus describing trends over time. So because we're appending that data, we're able to see a whole journey versus just one boxed view of the data. And another important thing to say, though, is event databases aren't to replace entity databases. They're just made to complement each other. So think of, say, you know your most active users from some queries that you've been running in your event database. You could then maybe go get more information out of your entity database, or the other way around. Say you want to know about the behavior of a specific user, you can then go look it up in the event database. So just more examples: a sign up, a login, upgrade, all types of actions. State info, so think of like a user, company, organization. And so how to apply some of these like data concepts. We use analytics to measure progress towards a goal, monitor health, test new hypotheses, provide value to our customers. A lot of it is testing these things before we run out of resources, aka money, and also just like exploring the data. But it's also important to not be just using analytics to like check off a box of, oh yeah, we use analytics and move on. But it's also important to be able to have like a very historic view and events over time to be able to do these things. So a common goal at a time is engagement. So app installs, deploys, messages, purchases. We also say a lot of times like 99% of mathematical, like analytics operations is just counting, because that's the core of most queries and everything that we're running, but there's just a bunch of fancy terms for it. So think daily active users versus and monthly active users, you're just counting per day. Then you have funnels. Funnels are super helpful. You're tracking a user through steps of their journey and then finding gaps, like where's there maybe an opportunity to figure out what is happening between when they started that recording and finished the recording that we could act upon. Then you have things like cohort analysis. A cohort is just a group of people that share some common characteristic over a certain period of time. So graduation classes from 2010 versus 2011, and just counting whatever you're tracking over time. Retention is just another form of counting. How many customers remain customers? How many users came back a second time? Do customers value my product? You're measuring retention by counting how many users did a certain action a certain number of days after their first usage. Here's a very specific example. Mike.com uses Keen to build out a whole analytics platform on their back end. This is a little bit older screenshot of it, but they're just counting reads, finished, shares, share rate, all things that are tangible, just counting of things and maybe doing some division. So with all this data, there's just a couple of things I wanted to touch on about being data informed. So what is a good metric? A good metric is behavior changing on the user's end or internally. So it's understandable. If you're busy explaining the data, you're not busy acting on it. So for a ride share, that would be rides requested. A good metric is comparative. It maintains context. So can you compare it over between two different things? In this context, maybe rides per day and then comparing days. And a good metric is meaningful. It centers around some core business goals. So a really easy one would be revenue. And based on thinking of good metrics, we think of how can we use those good metrics to build even better products. Iterations build relationships. So good products provide customers with value, but even better products provide high and dependable value, which can all be measured by return visits, retention, engagement. And the last thing I want to touch on is like common pitfalls that people do a lot of times. You have to be disciplined in your data analysis and collection. So confirmation bias. I have this gut feeling and I'm convinced, and so I'm only going to look at the data to prove my point. And I mean, everyone can at least confess to maybe doing that once before. Also leading the witness. So I'm developing analytics questions and user surveys, and I might have a little bit of a biased view that's going to give me bad and false data. And then lastly, correlation versus causation. Making the mistake at the time of analysis that correlation is causation. Just because you have two variables, x and y, does not mean x causes y and y causes x. And my favorite 99% correlation graph is the divorce rate in Maine with the per capita consumption of margarine. I'll let y'all decide if there's causation there, but yeah, that's it. And there's my contact info.
Thank you, Taylor. Does anybody have a question? If not, thanks again. Let's give her a round of applause. My man has a question here. Would you like Mike? Yeah, sure. It might be hot.
Did everyone on time? It's okay. Okay. So this is all very interesting to me, but in terms of the way that we understand and analyze the data, you said that there are, what, 3 different ways of understanding whether a particular product offers value by how often the click rate and how much people come back and so forth. But I feel like there's a big movement, and this may be a little too philosophical, but there's a movement away from that now to people saying that there's just too much of the product in our face all the time. Is there some way we could use the data in a way that doesn't necessarily use just those points?
Yeah, I mean, part of the thing is we are really conscious about the words we use. We try to be data informed, not data driven. There's other things to consider. I mean, my role in itself is something like I'm a community engineer. So I focus a lot on like, this is just an example, like community feels are like a metric kind of in my head, but I can't always, give exact numbers to that. But there are certain things where we can pair that with. So finding a good mashup of, just being informed while, still not totally just being heads down in the data and ignoring other things.